Suppose you want to calculate 2D properties of different chemical compound. So you head to the ZINC database and then go to the tranches. There are two options. One is 2D and one is 3D. And you want to calculate the descriptors or the molecular properties for the 3D compounds. So you select the 3D compounds from the ZINC tranches, and then you can see that there are 13K tranches, and you can go and select none, and whichever the properties do you like, they are based on LogP and the molecular weight. So it ranges from 200 until 500, and then LogP is -1 to 5. Okay. For instance, if you want to select this particular tranche with molecular weight of 300 and LogP of 3, okay, and you want to download that tranche. So you can see that the tranches are listed here, and you can directly download them. For the tutorial purpose, what I'm going to do is I'm going to select a few of them so that we can easily calculate the properties. And now you can see that I have selected a small tranche with having molecular weight 200 and LogP of 3. And then you select the SDF file and select URL or wget. And then it would download a file which is called the ZINC tranches.wget. And if you want to convert this into a bash script, so I'm going to do that here. So if you open that and then you just write hash !bin and bash, it will convert into a bash script. You save it, it will convert into a bash script. Okay. And then you save it as whatever the name that you like. In this case, I'm going to save it as ZINC db.sh, and then I'm going to make it executable by using the command chmod, and then download it by using the command sh zincdb.sh. And now you can see that all the files are being downloaded, because since I have selected a small tranche, I think it will be downloaded as soon as possible. Okay. So let it download. I think it will be finished in a couple of seconds. And each of the folder contains a zip file or tar file, I guess, .gz file. Okay. Each of them has contains stf.zz file. And I have written a small script. It's called extract SDF. You can also get it from any of the AI tools. I have also used AI tools to do that. So here you require two things. So one is you have to create a folder called tranches. Okay, that's your output directory, and you can extract all the files from the downloaded directory. Okay, some of the libraries you have to install by using pip, but now if you type in the script extract sdffiles.py and you provide the input directory, which is the downloaded directory, and -o your output directory, which is tranches, and if you hit submit, now you can see that all your SDF file have been extracted over here. Okay, they are not zipped file, but they are the individual files. Okay, this is the script that I have written, so I can upload it on my GitHub channel. Now, you want to calculate the properties. So I have written another script. Is called molecular properties. For that, you need RDKit library. RDKit is something which is very much helpful to calculate all the properties. You can install it via pip install RDKit, and it will be installed. Now, you want to calculate this. So for that, you want to calculate all these properties like molecular weight, TPSA, LogP, etc. Right? So for that, you need to create a text file, which you can do by using the command line ls, and then the greater than symbol, and you have the file.txt. So it will list all the file names from the directory. As you can see over here, there will be also file.txt that you have to delete. But yeah, this is the file.txt. What you have to do is, for this script, you have to provide this file.txt, which is containing all the SDF files, and then you have to give the directory name where the actual SDF files are, which is the tranches in this case, and you have to provide an output directory. So in this case, I'm going to make it as a processed molecules or something like that. Okay. So you create the output directory, you provide the file.txt with all the SDF file, input directory, and your output directory. Okay. So process dot underscore molecules, and now you execute the script which can calculate all the properties. So Python mole properties.py, as you can see, all the properties are being calculated. And if you open one of the files, you can see that the name, the molecular weight, TPSA, LogP, hydrogen bond donors, hydrogen bond acceptors are being calculated. And the calculations are pretty much accurate. I have compared it with Discovery Studio and also from Maestro. But RDKit is pretty powerful in calculating all these properties. Okay, you can see all those files have been, whether they have calculated or not. Right. So all these files have been generated. Now, what I'm going to do is, I have written some of the plotting scripts. Okay. So navigating through Excel files is quite hectic. So I've written some of the visualization script. I can upload it on my GitHub channel. And for this, what you have to do is, you have to provide, I'm going to plot only one example from this. So I'm going to copy one of the file location from here, and then I'm going to paste that. So I'm going to process only this particular CSV file. I'm not going to process all of them, but you can also process all of them. For example, I'm going to process only one CSV file, and for this you require matplotlib, pandas, plotly, the basic visualization software. You can install it via a pip package. Now, for this molecular plotting, as I mentioned, you require only matplotlib, seaborn, plotly, scipy, and also pandas for reading the CSV file. Okay, so provide the CSV file path, and then Python mole plotting tools.py, and it will generate comprehensive plots like chemical space, correlation matrix, drug likeliness, which will be easy to understand, what your components or what your small molecules are, in what chemical space they are, whether it is comparable for your selected libraries or the compounds that you have selected, all of them. So it calculates all that, so that you can get a visual view of all the properties. Okay, I have written another script. It's called interactive plot. That also I'm going to show you. And that interactive plot will help you to determine all these properties in 3D, interactively. So this is the interactive plot script. And again, you have to provide that same CSV file into it. And yeah, so you provide the CSV file, so it will create interactive plots in a web browser, probably in a Chrome or Firefox or Safari. So yeah, when you execute this particular script, I think it will create some of the interactive plots for you. And yeah, as you can see over here, it is now creating all the interactive plots. And this is your chemical space, molecular weight versus LogP. I'm going to make it bigger a little bit. Yeah, now you can see. So it is interactively displaying all the properties along with all your molecules, and this is the 3D chemical space where it calculates the drug likeliness categories like fragment like, lead like, etc. You can input as many as parameters that you require. This is just only for the example purpose, and this is your correlation matrix with the molecular weight to all the other properties, and this is also again the same thing in different plots. So you can use any sort of AI tools to do that. It's very easy to do. I also have another plot called QuickMD. It will give you a comprehensive. It's just the same, not as individual plots, but it will give you a comprehensive plot. And yeah, this is the way that you can analyze all the properties from Zinc database itself. You can also navigate to drug bank, chembl, etc., and download the STF files and do the same with this. Now it can show you molecular properties summary, and it will create a comprehensive a single plot with all the properties. So yeah, I mean this is the way that I calculate all the molecular properties of different STF files. I have all these scripts in a bin directory where I can anytime use it whenever I require, just to have a glance over the properties. And you can download as many as tranches from Zinc database. I have downloaded all of them because I'm doing some of the analysis with all the Zinc database. But you can choose whatever tranche that you like. Okay, and that's it for today, and thank you very much. I hope you enjoy my videos, and I will see you next time. Thank you very much.